Hello. Very warm welcome and very good morning to Exampur, guys. All right, so another day, another session for geography. Okay, so Exampur geography classes. So in the previous one, we have seen about the universe. Yes, we completed UN universe. We saw something about Geneva universe, and now the next, proper thing whenever you talk about the universe first, and then the next thing to talk about is the Earth. Okay, so from universe, and when we talk about universe, we are not talking about the universe. We talk about the solar system because that is the nearest to us, and we are uh, a little bit we can say we know more about our solar system than what is beyond our solar system. We know a few things which are beyond our solar system, but we are not sure about a lot of things which are above or which are much far away from our solar system. But in solar system, we have planets, we have named the planets, we know about their features, we have sent missions, okay, rovers, landers, fly past missions on those different planets, okay, and we have this idea to colonize Mars, okay, so that is also there. So yeah, so we know a few more things about our solar system than the entire complete universe. Okay, so the next thing is the Earth, and we'll talk about the Earth today. Different aspects, different features about the Earth, and then when Earth is completed, when everything is spoken about the Earth, then we'll move on to India. Okay, then we'll move on to India specific things. So it's the physical geography and the Indian geography. The physical geography starts with the universe and planets and everything. Then we talk about latitudes, longitudes, or different seasons, and then we go on to talk about oceans and atmosphere and land, lithosphere, biosphere, atmosphere, and all the everything in between. And then we talk about the Indian geography aspect. Clear? So that is how geography is based for your exams, for one-day exams. Clear? So that is geography for you. So we have a geography session, and yes, the dream. If you can dream it, you can do it. Yes, and dreams won't work unless until we work. Okay, so yes, the dream won't work unless we work. And if you can dream it, of course you can do it. Of course you can do it. So be a dreamer, be a dreamer, and be an achiever. Okay, so yeah. So without any further ado, let's just straight away dive into the session, and let's understand geography, and let's learn geography. Let's have fun with geography. All right. So yeah, 3, 2, 1, let's go. Yes, guys, let's go, guys, let's go. All right. So what are the learning objectives here? What are the learning objectives here? So learning objectives that we have in the session are, after completing this chapter, you will learn about the Earth and its motions. Yes. So we'll learn about the Earth and its motion. So basically, what is Earth and how our Earth, our planet, our home is made up, and different things, different aspects around it, and its motions. Yes, the motions are very important. We have two major motions. We'll talk about them in a jiffy. Okay. We will also learn about imaginary lines and time zones. Yeah, by imaginary lines, I mean latitudes and longitudes. So we'll talk about latitudes and longitudes, and the different time zones that we have on the planet, and why do we need them, and everything around them. Okay, so introduction. Yes, let me introduce the chapter to you. Okay, so the chapter reads, or the introduction reads, the Earth is the third planet from the sun. Yes, and it's a question that is asked sometimes. Which is the third planet from the sun? So people generally mark Mars, because you have to understand. Yeah, you first, whenever we talk about universe, the mnemonics should be very clear to you. My very educated mother just show us 9 planets. I've told you that. I've taught you that in the universe chapter. So yeah, Earth is the third. Earth is not the fourth. Earth is not the second. Mars is not the third. Earth is the third. Earth is the third planet from the sun. It is the densest and the fifth largest. Yeah, densest. It is very important. And which is the least dense? Which is the least dense one? Saturn. We already spoken about that. Saturn, the least dense, and the densest is Earth, and the fifth largest of 8 planets. So we are fifth largest. We are fifth largest out of the 8. Okay, so not a bad ranking. So so it's not a bad ranking by any means. Okay, and then we have it is also the largest. It is also the largest of the solar system's 4 terrestrial planets. So the only planets which are larger to Earth are your Jovian planets, or the outer planets, or the gaseous planet, that is your Jupiter, Saturn, Uranus, Neptune. Those 4 guys are bigger than the Earth, and Earth is the largest out of all the inner planets. Earth is the largest out of all the inner planets, and we have Venus. Venus is which is Earth's twins. That comes next, 6th largest. Mars comes 7th, and Mercury comes the 8th. Okay, Mercury is the tiniest planet. Okay, the smallest one. Okay, it is also largest. Yes, it is sometimes referred to as the world as blue planet. Yes, blue planet or watery planet because of the presence of water. Of course, it is also the densest. We have done this densest. Earth is thought to have formed 4.6 billion years ago. 4.6 billion years. Billion years is the age of the Earth. Is the age of the Earth, and is the age of the Earth, and 13.5 billion, 13.5 billion or 13.5, 12.5 in that neighborhood, or 14 in that neighborhood. We talk about universe, the age of universe. So age of universe is billion years. Okay, so 4.6 and 13.5, 13.6 and sometimes 14, sometimes 12. So in that neighborhood, universe's age. Okay, from the accretion of dust and gases. So universe was found when Big Bang happened, and slowly all the particles of the dust that they settled down. If there was a huge force, the kelvins of temperature. So slowly it all settled down, and then we had something in the shape of the materials which got together and became they came in the shape of geoid. Those become planets. We have definition for planets as well. We have seen that in the previous chapter. Okay, and rest which could not be formed as planet, they became asteroids and other things. Clear? So this is done. All right. Okay. So motions of the Earth, that is very important. We'll talk about that. So we have two big major motions, and that is written at the end. We'll come to this. First, we'll see this. The Earth's rotation. The Earth's rotation is the movement of Earth on its axis. Yes, Earth's rotation is the movement of Earth on its axis, and the Earth's axis is an imaginary line that goes through the North and South Pole. I told you in the previous chapter that if this is north of a planet, imagine this is Earth. This is north of Earth. This is south of Earth. So Earth is not like this. Earth is tilted. Correct? And Earth is tilted at an angle. What is the angle? The angle is 23.5 degrees. 23.5 degrees. That is the angle of Earth. That is the angle of tilt of Earth. Okay. So, so when you have this thing, now this is going like this. This is going like this. Now this is rotation. This is sun. Imagine this to be sun. This to be sun, and this blue to be water. I know this is bigger. My fist is smaller, but the sun should be bigger. But it's just to understand things. Okay. So let's just see. This is going. So this is moving like this. Correct. This is rotating. If it is rotating at only one place and not moving forward or backward, that is rotation only. Okay. So, but at the same time it is rotating, and at the same time it is also going around the sun. So it is rotating and going around the sun. So rotation is done, and going around the sun is revolution. So going around the sun is revolution. So this is rotation, and then by rotating it is going around the sun. This is revolution. So rotation and revolution. I am drinking water from Earth. Blue planet. The color is blue, so blue planet, and water planet. So yeah. So I had some water from Earth. Okay. So north and south poles. The Earth rotates from west to east. This is the most important one. Earth rotates from west to east. Try to remember it because it is generally asked straightforward in the examination. The rotation of Earth is from dash to dash. It's from west to east. And there's a very simple trick I'll share with you to remember it, and to remember it in such a way you will never forget, or most likely to understand it. See, the sun rises in the east. Correct? We all know sun rises in the east. So when sun rises in the east, Earth every morning goes to meet the sun. So Earth goes to meet the sun every morning. So sun is in the east, so earth is going to east and coming from where? Coming from west. So earth is coming from west and going to east every single morning to meet the sun. So which means we are moving from west to east. We're rotating from west to east. Again, remember this way. We are going from west and we are coming from west and we are going to east to meet the sun, because sun rises in the east. Okay. But otherwise sun doesn't rise, sun is stationary as a ball of fire. We are only, moving that way. But just to understand things. This means that the sun, the moon and the stars appear to rise in the east and set in the west. Okay, so all those, they appear in the east and they set in the west. Okay, so sun rises in the east and we come from west to east, and the sun, it rises, and this thumb is my east, so it's going to east, and the sun, it sets, the stars, it set, they set in west, so they go like this. If you rise in east, obviously you'll set in west. Okay, now next is the earth's revolution. The earth's revolution is the movement of earth around the sun. The earth's revolution is movement of earth around the sun. Yes, the movement around the sun, of course. The earth revolves from east to west. The earth revolves from east to west. We already discussed this. Clear? Okay. Now the two motions that we're talking about. Earth has two major motions. Earth has two motions. One is your rotational motion. We have discussed this. And other is revolutional motion, or also called as orbital motion, or in the orbit. Clear? This is done. So yeah. Okay. So rotational motion. The Earth's rotation is the rotation of the Earth on its axis. The Earth's rotation is the rotation of the Earth on its axis. Yeah, it should move on the axis. The Earth rotates about 24 hours. It rotates in about 24 hours. We all know that. What is the rotation of Earth? What is the rotation of Earth? What is the rotation of Earth's rotation is 24 hours. We all know that. It is not 24 hours. It is not 24 hours exactly. It is this exactly. What is it? 24 hours, yes, but exactly 23 hours, 56 minutes and 4 seconds. 23 hours, 56 minutes and 4 seconds. That is the rotation of, and also in the examination, many questions have come in CHSL, which directly say that, we directly ask you that, what is the rotation of Earth, which directly asks you what is the time frame or what is the duration of the Earth's rotation. 23 hours 56 minutes 4 seconds, option number 1. 23 hours 54 minutes and 5 seconds. 23 hours 58 minutes. Okay, so they change this, and they'll change seconds also. So this is also this also happens, and this question exactly, this data exactly comes. So you have to remember this. There's no denying the fact. Okay, so you have to remember this. 23 hours 56 minutes and 4 seconds. Clear? Just repeat once again with me. 23 hours, Earth's rotation is 23 hours 56 minutes and 4 seconds. 56 minutes and 4 seconds. Clear? So remember this data, this numerical value. Next, the rotational speed of Earth is 1667. So this is also important. Yes, the rotational speed of Earth is 1667. And Earth, what is the shape of Earth? Like every planet, Earth is geoid. Like every planet, the Earth is geoid. Geoid shape means, okay, understand, I've told you, understand it's like a tennis ball. A tennis ball. Place the tennis ball between your thumb and your index and your middle finger like this. Okay, if this is the ball, then put it like this. So, and when you have the ball in your hand like this, try to squeeze the ball. Imagine you are squeezing the ball. So when you squeeze the ball, your thumb is applying pressure from down, and from your index and your thumb, your middle finger applying pressure from the up. Right? What will happen? From these 2 points of contact, the ball will get pushed inside. The ball will get pushed inside from both these points. And what will happen? From the middle part of the ball will come out. Right? Ball will expand at the equator region, or at the mid section. The ball will expand from the mid section because you are compressing it, and it is flat at the poles. So flattened at the poles and bulge out at the equator. Flattened at the poles and bulged at the equator, that is a geoid shape. that is a geoid shape. I'll write it for you. Flattened at poles, bulged at equator. So flattened at the poles and bulged at the equator, that is your geoid shape, and that is the shape of Earth, like all the planets. And what will happen? And what happens? Earth moves the fastest at the equator. At the equator, it is moving fastest. What is the speed? 1667 kilometers an hour. That is the speed. At the very top, at the poles, it is not moving. The speed is zero. At the poles, at the exact that point, at the poles, it is zero. Okay. So you have to remember this point because it is asked in the exam. Where the rotation is zero, equator, poles, okay, Tropic of Cancer, Tropic of Capricorn, the answer would be your poles because it is zero at poles. Okay, and from the fastest in the midsection to the poles, it slowly decreases and then it becomes zero. Correct? At the equator, it is 1667 kilometers an hour, and then it goes up or down. Then you slowly go to the North Pole, to the South Pole. It eventually becomes zero, which means it is decreasing as we go up or down. Clear? So that is the case here. And I'll tell you an important fact, a very interesting fact, and the fact is, you know, if you'll see, then you'll find a lot of space stations, rocket launching stations are very close, are as close as possible to the equator. Okay, so if you have this, if this is Earth and this is equator, okay, 0 degree equator, so you'll see a lot of space stations, a lot of, not space station, but rocket launching or spacecraft launching centers. They try to be very close to the equator. Why? Because Earth's rotational speed will help them, escape the Earth's gravitational pull or achieve the escape velocity, and they can go out in the atmosphere, out of the atmosphere, and they can really go out into the space. Clear? So if you are very close to the equator, the Earth will help you. And what is the help? The Earth, the rotation will help you, and also it will save majorly on fuel. So we'll be saving a lot of money on fuel because Earth is helping us. Correct? Yes. So that is why we have one at Sriharikota in near the Andhra Pradesh region. Correct? But now we are building a new one in Tamil Nadu. We are trying to be or close or very close to the equator. Correct? Chalo. This is the thing I want to explain to you. So, yes. Okay, so next is, at the equator, the length of the day and night are equal. So, at the equator, everything is equal. Equator, equal things. Okay. Also, you'll see other things. At equator, a lot of things are equal. So, in the exam, if you have confused where things are equal, if you see equator, equal. Okay, try to take that. No worry. So we're joined by Bindu. Bindu is saying, really awesome teaching, sir. Thank you so much, Bindu. Thank you so much, Bindu. So thank you so much for those words. Was for the very kind and humble words. Thank you. Okay. So yeah. So next is, the rotation of the Earth causes some very significant changes on the Earth. They are also now the most important point of the entire, what you can see on the board, the most important points are coming now. Okay, so have your full attention here. So most important points are coming now. Okay. Okay, so what is the point number one? So what is the point number one? First point, we are only talking about what happens when the Earth rotates. What are the causes for, what are the consequences of Earth's rotation? In the exam, we have straight question from this. What is a consequence of the rotation of the Earth? A, B, C, D. You have to find out. See, number one, days and nights, they happen because of the rotation of the Earth. Obviously, 100% yes. We have Earth, yes, our blue planet, Then we have Sun is throwing us light. It's like a big night bulb. It's like a big bulb. So whenever you have bulb, you have light. It's a bulb. It's a light. It's a light source which is continuously on. There is no switch off button. Correct. So if you have light, it's on. If you don't have light, it's off. So Earth, this part of the Earth is facing sun. Correct. This is the part which is receiving light. Correct. That means we have day here. That means we have day here. And the part which is not facing the sun, we don't have light. If we don't have light, that means we have night there. Correct. Now because Earth rotates, so days from this part become night, and night from the previous part or the backward part became day. So days and night happen because Earth rotates. Imagine a scenario where there is no rotation, where there is absolutely no rotation, then sun's heat or sun's light would be continuously in one part of the world. Continuously, there will be no crops, there will be no cloud, there will be no crops, there will be no agriculture, because sun's intense rays are killing everything. Extreme heat every time killing everything. Then we have the area which has night always, which has always has night. So because of night, the plants adapt to different things. We don't have the same plants. We might don't have the same conditions, because extreme heat, extreme light, extreme cold, extreme dark. So Earth would have been a very different place. We would have been very different people. We would have adopted people who lived in the dark part would have never come to dark part, in the light part, and the light part people never have won to the dark part. So the life would be different. The Earth would have been different. Humans would have been very different. It's all because of simple rotation. It's all because of simple rotation that we are the way we are. Okay. So we should be very thankful to every single thing. Even it is the smallest of thing, it is in the grand scheme of things. Okay. 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 So first and foremost, days and nights. Okay. So I'll write D and N. That means days and nights. Days and nights are caused by rotation. Next one. The direction of the flow of winds, and ocean currents changes because of the rotation of the Earth. Because of the rotation of the Earth, yes, because of the rotation of we have winds. We have winds. We have different wind currents. Flow of winds is because of rotation. And when winds, they high flowing jet streams, high majorly flowing winds, when they come in contact with the ocean water, that also they also drag it. Okay, and the water also moves because of the rotation. So because of the rotation of the Earth, we have flow of winds and we have flow of ocean currents. Okay, you do not have to remember all the points, only remember the keywords. Entire geography is this big, and when you remember only the keywords, because questions are only formed on keywords, there will be no extra data, no extra theory asked, only exact precise data points, exact precise keywords. So only on keywords. If this is the data, if this is the geography section for you, then exact keywords are this much. Exact keywords are, only remember keywords, you will be a happy person. Revising geography would be much easier and you will love geography. Geography is an amazing subject. Okay. So I'll write, so this is one, I'll write wind/ocean currents. Okay, wind/ocean currents. And the last one is tides. They rise and fall regularly because of the rotation Earth. Yes, also because of the rotation, and also it is held by the gravitational pull of the moon. So gravitational pull of the moon also helps in the rising and falling of the ocean water, called as tides. Okay, so 1, 2, and 3. I think it is TW is tide water. Okay, or we'll say T only. Let's say T only. Tide. Okay. Clear? So this was about rotational motion. So rotational motion of the Earth is important. And what are the key takeaways? Day and night because of rotation. Wind and ocean water because of rotation, and we have tide. So these three things because of rotation. And Earth's rotation speed is 1,667, 0 at the poles. That is why a lot of space launching stations are near to the equator. They are as near to equator as possible. Okay. We have Russia. Russia's space launching station is not in Russia. It's not in Russian continent. It's not in the territorial borders of Russia. It is in Kazakhstan. They have leased it. Okay, they have not put it in their own country. It's in Kazakhstan. It was before the breakup of USSR, Soviet Union. It was there, so it was under an agreement. Okay, so we are also trying to build a new one. We have it near, I think, Sriharikota in Andhra Pradesh. Now we are trying to make one very close to Tamil Nadu, because Tamil Nadu is even closer to equator. Correct. In US, if you see US map, US map space station, space launching center is at the point which is very close to equator. That is Florida. That is state of Florida, the elongated, bulged out part. So every country wants to be as close to as. And France is not in France. It is in French Guyana. French Guyana is a country in South America, which is very close to equator. See, in the examination, if you find yourself in doubt where it would be, find a place equator to the closest to the equator. There it will be, because now you know the logic behind it. Now you know the geography behind it. Okay, because Earth is 1667 and poles 0. And yes, you have to remember this number: 23 hours, 56 minutes, 4 seconds. Remember, repeat after me: 23 hours, 56 minutes, 4 seconds. Once more, the time taken by Earth to complete one rotation is 23 hours, 56 minutes and 4 seconds. Clear? Very nice. Superb. I'm sure you must be repeating with me wherever you're sitting. And when you're watching my sessions, try to participate in the comment section. That is really helpful, because it helps to establish a two-way communication. And studying is never one-way communication. It should be a two-way communication. Correct? I say something, you say something. I ask something, you answer. You ask something, I answer. It should be that way. That is when the subject really blossoms out. Clear? And you really fall in love with the subject. That is my idea. If you love a subject, you will never leave it. You will understand to the very core. The subject will call you. It will attract you. Okay. So this is done. Rotational motion is done. Let's see the next one. Next one is your revolutional motion. Yes. So another big one, another important one. Number 1, the motion of the Earth around the Sun in an elliptical orbit is called revolution of the Earth. Okay, as simple as that. They are defining what was rotation on the axis. As simple as that. On the axis, rotating on the axis is rotation. But what is revolution? What is revolution? Around the Sun in an elliptical orbit. Now, what is an elliptical orbit? Now, this is Sun. This is an elliptical orbit. Okay. See, so this is the elliptical orbit. This is an elliptical orbit. Okay. So rotating in an elliptical orbit, that is your rotational motion. Okay, the next one is the Earth's revolution around the Sun takes around, now, yeah, we've always said it is 365 days and 366 in a leap year. But guys, it is not that. A revolution is also a different number. It is 365 days, 5 hours, 48 minutes and 45 seconds. It is 365 days, 5 hours, 48 minutes and 45 seconds. Remember, for revolution it is 48 minutes, rotation it is 46 minutes. Do not confuse the minutes, because in the examination you will find both the options. The examiner knows where the student can go wrong, because examiner was once a student. He was himself a student once. Correct? So he knows where I can go wrong, where students go wrong. Okay. So 365 days, 5 hours, 48 minutes and 45 seconds. Clear? All right. Now, you see one thing, 5 hours, 5:48, which is close to 6 hours. Correct? Which is close to 6 hours. So this 6 hour is added every single day, every single year. So once Earth goes around the Sun, we have an extra of 6 hours. Okay. Next year the Sun completes. Again we have extra of 6 hours. Extra of 6 hours. Clear? Now the third year again the Sun goes out. So takes one revolution around the Sun and completes in 365 days, 5 hours, 48 minutes, 45 seconds. Again we have extra of 6 hours. Correct? Now fourth year, what happens? Fourth year again the Sun goes out. So the Earth goes out and makes one revolution and again comes up with 6 extra hours with us. Now what to do, guys? What to do with these 6 extra hours every single year? So what we have done a very important, very smart thing. We're like, okay, Earth, you want to take 6 extra hours? No worries, take it. Take extra 6 hours. But at the end of every fourth year, at every fourth year, what we'll do, we'll combine all the 6 hours together. We'll combine all the 6 hours together, and what we'll do, we'll make it 24. We'll make it 24. Now, whenever we see 24, like, 24 hours, 1 day. So, extra 1 day every time every fourth year, extra 1 day. So, 1 day need to be accommodated somewhere. So, we've got hold of February. February, come to us. Now, you will have 29 days after every fourth year, after every third year, after fourth year. At every fourth year, you'll have 29 days. So, we're like, okay, no worries. So, every fourth year, 366 days, that is why we have a leap year. Now you know the concept of leap year. Yes, so leap year. Now we know the concept of leap year. Yes, we do 100%. Okay, so because of extra 5 hours, 48 minutes and 45 seconds, it leads to an addition of 6 hours every single year. So at fourth year, we add everything together and we make it one leap year. Okay, do not forget this. Whenever your young cousin, your young sibling, okay, and they ask you why we have 29 days in February, okay, and why we have leap year every fourth year, so do not just tell them the answer. Just raise your collars, roll up your sleeves, and then tell them the answer. That is because of this fact. Okay, they'll be in awe. Bhaiya Didi is so knowledgeable. Okay, have that impression on them. All right, let's see the next one. Next is like the rotation of the earth, revolution of the earth also causes some significant changes on the earth. They are as follows. Okay, so rotation is done. Now revolution. We'll talk about revolution. Okay, number one. So we'll just rub this one. Okay, now important takeaways. The seasons are changed because of the revolution of the earth. The seasons are changed. Very, 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 very important. Okay, because we have seasons, that is why life on earth is little scenic, little beautiful. We are like, oh, summers is this, oh, winters is this, there are snow, there are ice, oh, rainy season, monsoon. We have Bollywood songs on monsoon. We have Bollywood scenes. Okay, we have poems on monsoon, right? So it's all because of seasons. The life is very beautiful on earth because of we have seasons. Spring season, we have blossoms. We have autumn, which is also a beautiful way, but in its own way. It's little. It has a little dark shade to it, dark hue to it. All right. So seasons are there, or seasons change because of revolution of the earth. Because of the revolution of the earth, and the length of days and nights changes in northern and southern hemisphere at different times of the year because of the revolution of the earth. Exactly, yes. For example, in the northern hemisphere, we are experiencing winters now. We are facing winters now. But what about southern hemisphere? Southern hemisphere, it's summer. So if it is summer in southern hemisphere, it is winter in north. It is summer in north, then winter in south. Southern hemisphere. South means southern hemisphere. Okay, southern means under the equator. So I'll just draw it quickly. If this is the earth, this is the mid part. Equator is the mid part, which cuts the earth into two imaginary halves, two imaginary equal halves. So it is summer here, it's winter here. If it is summer here, then it is winter here. Okay, so it's more like that. So it is more like that. Clear? So seasons change and length of days and nights. And when we have winters in northern hemisphere, if we have winters, the days are shorter. In northern hemisphere, the days are shorter. Now we are experiencing winters in the north. Yes, the days are shorter. By days are shorter means the duration of sun is shorter. For example, in the summers, the sun rises at 5:30 in the morning and sets at 7 in the evening. That is the duration. That is sun available in the sky in summers. But in winters, the sun is getting out a little late. Let's just say around 7:30. It is coming out at 7:30 or 8 a.m. It is coming out at 8 a.m. and it is setting at 4, it is setting at 5, it is setting at 6. So the time frame, the duration you can see the sun up in the sky in the winters, in the day, it's small, because in winters the duration of the sun is smaller. In the duration of the sun is smaller, but in winters and in summers the duration of sun is is larger. So in northern hemisphere it's sun, in the summers longer duration. In southern hemisphere it is winters. Yes. So whenever we have sun, whenever we have long day, whenever we have a long day, then we have a short night. Whenever we have long night, then we have short day. Okay, so that is the way it should be. Okay. Okay. So all clear by now? So we'll discuss these things in detail also. This is just the tip of the iceberg. Yes, this is just the tip of the iceberg. The real detailed things will be discussed. Yeah, when we go further deep in the chapter, we will discuss everything in detail. Okay, but it's just the two of things we want to share with you. So seasons, and the other thing is length of days and nights changes in order. Yes. Length of days and nights. Why why I am specially writing these? Because these keywords are very, very important. Why? Because straight direct question is asked from the keyword. In the examination, you don't have to write in the CHSL examination, CGL, or any one-day examination. Nobody is asking you to write a big answer. Okay, no one is asking you to write subjective question. No, until you're taking the civil services examination, nobody asks you to write big long answers. So you just have to remember the keywords. So what are the keywords here? These ones, this date, okay, extra, this time frame, extra time, and the concept of leap year. Why do we have leap year? Yes. Clear? Chalo, we'll see the next one. Okay. So yeah, this is Earth fact sheet. This is Earth fact sheet. So we'll talk about Earth's fact sheet. Okay. Age of the Earth, 4.6 billion years. You have to remember this because this data, this number is exactly asked. Because it's a very famous number, 4.6 billion years. It's a very, very famous, and it is constant almost everywhere. You will not find much, because some data are very difficult. For example, you will find Earth's Everest height as 8848 meters. Yes. It is constant everywhere. This is constant everywhere. So it is generally asked. This is also constant everywhere. 4.6 billion years, age of the Earth, it's constant. And it is asked, it has been asked in the examination. So it can be asked again. Okay. So you have to, so wherever I mark a tick, wherever I say you have to remember this, that means you have to remember that. Okay. Mass, 5.9 10 to 24 kg, not asked. Okay, it's not asked. I have not marked a tick here at the end, so it is not asked. So you don't have to remember. You have to understand. Okay, so it's pretty heavy. Earth is the densest one. Earth is the densest. Yes, so that we have to remember. Densest. Next, volume, 1083 10 to the power 12 kilometer cube. So not asked in the exam. This data is not asked. Shape of the Earth, yes, this is asked. What is the shape of Earth? Elliptical, oval, geoid, irregular. They won't ask irregular, but these are the things. Okay, so geoid is the answer. Radius of the Earth, yes. 6,400 kilometers, yes. Yes, you have to remember. Radius 6400, and rotation of the Earth was 1667. Okay, kilometer an hour. Okay. Total surface area, not asked in the exam, just for your reference. And since we're talking about total surface area of Earth, just to tell you, Earth, on the Earth, India occupies around 2.4% of land. 2.4% of the entire world's land is with India. Okay, India 2.4, and 17% of the world's population, 17 to 18%, because of previous data, it could be 17 to 18%. 17 to 18% of the world's population is in India. Okay, 2.4% of the land, 17% of the population. Clear? Now, rotation, yes, it will be asked. Why? Because it has been asked. So you have to remember this. Earth's fact sheet. Okay. So it's more like, all the important things at a glance. All the important things at a glance. Okay. So for very, very easy and quick for revision. Okay. Again and again, I'm telling you, if you're someone new to the preparation, guys, include reading, learning, that is part one. Include revision in your preparation. There are three pillars to success: revision, learning one, revision two, and third one is taking papers, taking exam, mock papers, revising previous year papers, mock papers. Practice them. If you make any mistake, understand the mistake, get it rectified. Okay, do not let it pass. Get it rectified. Once you get it rectified, and do not commit the same mistake. Commit a new one and learn something new, but do not commit the same mistake. Okay, and then again read, again learn, again revise, again give paper. Read, revise, give paper. So you have to get into that cycle, and there are three pillars of success. If you are not following any one of them, if you are only reading and not revising and not giving paper, not going to help. If you're not reading but you're like, I will give previous year paper, not gonna help. You have to have three things together. And if you do these three things, nothing can stop you in the world from cracking any paper of the world. Yes, any paper. Civil services also. Okay. Examinations in India, they do not, with the exception of IITs, they don't test your, intellectual level. It's more like discipline, consistency, to be able to move, small targets every single day, and eventually at the end of the month you'll have one big target. So you have to do simple, small things every single day. Discipline, consistency is the key, because we need patience. People don't have patience. They're sitting, they'll take up the mobile, they'll go away, we'll read tomorrow. There's no tomorrow. There's absolutely no tomorrow. If we'll say tomorrow becomes today. Tomorrow will become today. So there is no tomorrow. You never get to tomorrow. You only get to today. If you say tomorrow I'll do, tomorrow will come and become today. So tomorrow is in future. It remains in future. It will always in future. It is always today, and it is always now. You cannot guarantee what happens after 5 minutes. You cannot guarantee what happens after 1 hour. You can only guarantee now. Now you want to sit down. Take up the book, sit down. Sit and sit. Okay. Sitting at one place for a long duration will lead you far in life. Okay. That's the mantra. It's a very basic, very simple things. People think it's going to be this very, hanky-panky and all this amazing things. No, it's very simple, straightforward. Okay. So revolution, 365 days, 5 hours, 48 minutes. Yes, will be asked. Can be asked. Not will be asked, can be asked. Yeah. Next is orbit speed around the Earth. 29.8 km per second, 29.8 km per second. Not asked. Generally not asked. Not asked. Mean surface temperature. It varies. It varies. It's not a constant number because of global warming, climate change. The number, 14 degrees centigrade, the number changes. Deepest ocean point, 11,034 meters, Mariana Trench, Pacific Ocean near Japan. Yes. Now it's a very important thing, a very interesting I want to tell you. See, the deepest point in the planet, on the planet Earth, is Mariana Trench in the Pacific Ocean near Japan. The highest point on the Earth, I've told you, it is 8848 meters. 8848 meters, Everest. Yes. 8848 meters is close to 9,000 meters. 9,000 meters is your 9 kilometers. So this is near about 9 kilometers. And this is almost 11 kilometers. Yes. So the highest point of the Earth is actually shorter than the deepest point on the Earth. Okay. And that's a very interesting fact. And there's one very interesting fact I want to tell you. You guys won't believe, but geography is full of ironies and full of such contradictions and such amazing fact. You will love it. So shall I write here? I'll write here. Okay. we have some space here. I will write here. Okay. See, so deepest point is done. Topmost point is done. You know what? On the ocean floor, there are really amazing structures. On the ocean floor, there are amazing structures. And near Hawaii, US, there is a mountain. There's a mountain beneath the ocean. It is in the ocean. It is on the ocean floor. It is on the ocean floor. And you know what is the height of it? It is near about 12,000 meters, near about 12 kilometers up straight. But it is in the ocean, and the name is Mount Kia. Near about 12,000. Near about. Okay. Mount Kia. So what is inside the ocean is actually much bigger than what's on the planet Earth. Okay, and the deepest point is clear to you. Okay, but why Mount Kia is not considered as the highest mountain? The sole reason, because it is not on the surface of the Earth. It is underwater, so we don't consider that. Similarly, you know what is the biggest continent? Which is the largest continent on the planet Earth? Largest continent? Everyone will say Asia. Guys, Asia is not the largest continent. It's actually Antarctica. Antarctica is the largest continent of Earth, but we do not consider it because nobody lives in Antarctica. Nobody residentially lives in Antarctica. Nobody has the addresses, okay, domicile, Aadhaar card of, of Antarctica. It's more like research scientists, they go on deputation because it is one of the most unhospitable places on the planet Earth. Okay, so very, 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 very difficult even to stay for even for 5-10 seconds. It is extremely, extremely cold. Okay, so deepest point is clear. Okay, time coordinates of the Earth, longitudes, and temperature coordinates, latitudes. The longitudes, latitudes we'll deal in detail. Do not worry, we'll talk about them in detail. Yes, so rotation complete, revolution complete, and Earth's fact sheet is complete. And the next class we'll talk about seasons, and then we'll move on. Okay, chalo. So so this was the class for the day, and we'll wrap up here. Tomorrow, same time, same place. We'll have some more things on it, and we'll take the chapter forward, and we'll talk about latitudes, longitudes. We'll talk about then we'll talk about seasons. Yeah, why seasons change, and season part is very, very important because we have straight questions from the season part. We have questions from equinox. We have questions from the spring equinox or autumn equinox, different, and so such things will be discussed. Okay, so I'll take your leave, guys. I'll take your leave. So it was fun session. So if you're someone who's still watching the session, I would request you to give a thumbs up so that I get to know that you were watching it. So I get to know that you were watching it. So if you're someone who's watching it, so it would be really great if you can just drop in a thumbs up and press the like button. Yeah, guys, press it, please. Press the like button. Share the session among your friends. Okay, among your friends. So Bindu has dropped in a really sweet comment. Really awesome teaching, sir. Thank you so much, Bindu. If you're still watching it, I would request you to give a thumbs up and share the session and like the session, guys. Clear? Chalo, I'll take your leave, and it was fun teaching you guys. So I'll see you guys tomorrow, same time, same place. Till then, bye-bye and take care. Thank you, guys.